Welcome back. In this video, we are going to solve problem 13-10 that is taken from chapter number 13, Buckling of Columns, and book name is Mechanics of Material by R.C. Hibbeler, 9th edition. So statement is a column is constructed using 4A992 steel angles that are laced together as shown. The length of column is to be 40 feet and ends are assumed to be fixed, connected. Each angle shown below has an area of 2.75 square inch and moment of inertia IXIY is 2.22 inch power 4. Determine the distance d between the centroid C of angle so that column can be supported an axial load of 350 kips without buckling. Neglect the effect of lancing. So these are the four angles that are laced together. These are the lacings there, and the moment of inertia of each angle about the centroid IX and IY is given as 2.22, which are same, having area 2.75 square, 2.75 inch square. The column is assumed to be fixed connected. So you have to find this distance d between the centroid of these two angles. So let's start with the solution. So what we are doing is that we know that this critical stress is equal to pi square EI divided by L square. Critical stress is the largest stress, largest load without buckling of the column. So this is equal to pi square EI over LE square. Now Euler, this is what we call Euler formula. Euler's formula is valid. We can apply this formula only when your critical stress is less than the yield stress. So how we'll find critical stress? So critical stress is equal to critical load over area, that should be less than yield stress. So critical load is 350 kips without buckling is given. So 350 divided by area. So there are four angles. So 4 multiplied by the area of each angle, which is 2.75 inch square. Okay, that should be less than yield stress. So what we are going to do is 350 divided by 4 multiplied by 2.75 is giving you 31.81 KSI, and this should be less than the yield stress. So what is the yield stress for A992? We will go to the property table. So from average mechanical properties table, at the end of appendix we will get this sigma yield, and with that we will also get the modulus of elasticity. So how you will get that? So you have to go to the end of the book, average mechanical property, and in that you have to look for A992 steels, that is having 50 KSI yield stress and 29 into 10 raised to power 3 KSI modulus of elasticity. So I will write it 50 KSI, and that is 29 into 10 raised to power 3 KSI. Now you can see your 31.81 is less than 50 KSI. So it means Euler formula is valid, and we can apply this formula. Euler formula P critical is equal to pi square EI divided by LE square. Now in this we have this E value, we do not have I and LE. So what we are going to do is that we will find LE, and we know that LE is equal to K times L. What is K? K is a factor, and it is given in the question that ends are assumed to be fixed connected. So for that you have to go to again towards the book, and in chapter number 13 you will get this value of K. So here you can see that there are four cases. So our case is both ends are fixed, so it means that K is 0.5. So L is equal to 0.5 L. So I can write K is 0.5 and L length is given as 40 feet. So 40 is converted into inch. So 1 inch is equal to 1 feet is equal to 12 inch. So it will be this one. So effective length is this one. Now what about moment of inertia I? So I will write I. We know that if you take the horizontal mid of the horizontal line at the mid of this whole section, similarly vertical line passing through the mid of whole section, so you will get this point O. So this is the centroid of this whole section, and you can see that each centroid of this angle is away from it. So moment of inertia will be equal to, either it will be equal to Ix plus AD square, and is also equal to IY plus AD square, because it is symmetrical about horizontal as well as vertical axis. So you can take any one of this. So I will take Ix is equal to, as there are four angles, so I can write 4 multiplied by Ix, which is given as 2.22. So 2.22 plus area, which is 2.75 square inch. So 2.75. And what is d square? So d square is distance from this neutral axis till the centroid of this section. This is this distance d, and that I will write it this distance. So you can see this whole is kept small d, so this will be equal to d divided by 2. So I can write d divided by 2 whole square. Okay. Now what we will do is that I will be equal to, if you multiply 4 with 2.22, that is 8.88 plus 2.4 multiplied by 2.7 into this term will give you 2.75 d square. Now you have each and all values, just plug it in this formula. So we know that P critical is equal to pi square. E is how much? 29 into 10 raised to power 3. I is 8.88 plus 2.75 d square divided by LE square. So LE is 0.5 multiplied by 40 multiplied by 12 whole square. And we know that critical stress is the maximum axial load that can be used without buckling, and that is given as 350 KSI. So 350 is equal to pi square multiplied by 29 into 10 raised to power 3 multiplied by 8.88 plus 2.75 d square divided by this LE square, which is 0.5 multiplied by 40 multiplied by 12. Now we need this d square term, so I can write this as 350 multiplied by 0.5 multiplied by 40 multiplied by 12 whole square divided by this term pi square multiplied by 29 into 10 raised to power 3 is equal to 8.88 plus 2.75 d square. So if you calculate this term, 350 multiplied by 0.5 multiplied by 0.5 multiplied by 40 multiplied by 12 square divided by this term pi square, which is this value, multiplied by 29 multiplied by 1000. So that is equal to this 70.43 is equal to 8.88 plus 2.75 d square. So 2.75 d square will be equal to 70.43 minus 8.88. So answer minus 8.88 is 61.55. So that is 2.75 d square, and d square will be equal to 65. Sorry, this answer divided by 2.75 is equal to 22.38, and if you take the square root of this answer, that is D is equal to 4.730 inch. Now we will check whether it is correct or not. So you can see here that uh, from this y-axis till the end of this angle, this is 2.06. So this will be also 2.06. And this D is distance from centroid to centroid. So your D should be greater than 2 multiplied by 2.068. Let's check. Your D should be greater than 2 multiplied by 2.068. So 2 multiplied by 2.068 is 4.136. And your D is 4.730 inch. So it means that this answer is okay. So D is distance between center to center of angle is 4.730. That you can take either this one or this one. You have to maintain this distance. D is 4.730 in order to support this load without buckling. And that was all about this problem 13-10. I hope you have enjoyed this video and you have learned from it. Those who are new to my channel, then subscribe it and don't forget to press the bell icon so that you can get notification about my latest videos. If you have any question, you can ask me in comment section. Thank you for watching.